This lecture, I'm going to show you something very important. After more than 30 years in infrastructure, I've seen many major technology shifts. Okay, I've worked through the physical server era, I've worked through enterprise networking, I've worked through virtualization. Then came the cloud. And when AWS became mainstream, the AWS Management Console felt revolutionary. For the first time, you could build infrastructure in minutes instead of waiting weeks for hardware. But today in 2026, click through AWS Console manually is no longer a sign of speed. In many cases, it's actually a liability. Manual cloud configuration is hard to repeat, it's hard to audit, it's hard to govern, and it's very easy to get wrong. That is why infrastructure as code became so important. Right. So Terraform gave us a way to define cloud infrastructure in repeatable version control code. But now we are entering the next major shift. AI is beginning to change how infrastructure is designed, and that is what this lecture is about. I call this idea automating the architect. Now, let me be very clear. Okay, I'm not saying AI replaces the cloud architect. I am one of the cloud architects as well. I wouldn't want to be replaced by an AI, would I? Right. That is not the message. The message is that AI can eliminate repetitive infrastructure drafting so the architect can focus on higher value work. Resilience, security, cost, compliance, governance, and scalability, and business outcomes. So in this demo, I'm going to show you a flow that brings together three powerful technologies: AWS Bedrock, n8n, and Terraform. AWS Bedrock acts as the intelligence engine, and it acts as the orchestration layer. Terraform becomes the infrastructure as a code output. And the architect remains the reviewer, validator, and decision maker. So let's just start with the problem. For years, cloud architects and engineers have spent countless hours clicking through the AWS console. Create a VPC, add subnets, configure route tables, attach internet gateways, create security groups, set up EC2 or containers, configure load balancers, create IAM roles, right? Set up auto scaling, add logging and monitoring. Now, this is fine when you're learning AWS. It's also fine for a quick demo, right? But for production infrastructure, manual console work creates serious problems. First, if I build a complete AWS environment manually today, can another engineer reproduce that exact architecture 6 months from now? Maybe, but probably not without mistakes. Second, it is hard to audit. Who changed what? Why was the change made? Was it approved? Was it tested? Was it reviewed? Third, manual configuration creates drift. The environment you think you have and the environment you actually have slowly become different. And fourth, manual work creates compliance risk. So if you're working in healthcare, finance, legal, education, or government environments, you need evidence, right? You need documentation, you need controls, you need consistency. So the first big point is this. The AWS console is useful, but manual console configuration does not scale as a production operating model. Infrastructure as a code solves part of that problem, right? But now AI can help us solve the next layer, the design layer. So instead of starting from a blank Terraform file, we can start from an architectural intent. Now let's look at the pipeline, right? In this demo, we're not simply asking an AI chatbot to write some code. That would be too shallow. What we're designing is a workflow, a repeatable architecture pipeline. The process begins with an architecture prompt. This is where the architect describes the business and technical requirements in plain English. For example, design a secure, scalable AWS architecture for a SaaS web application. It should include a VPC across 2 availability zones. It should include public and private subnets. It should include an application load balancer. It should include ECS Fargate. It should include RDS and private subnets. It should include CloudWatch logging, and it should produce Terraform modules. That prompt is then sent to AWS Bedrock. It interprets the intent, It defines the required AWS services. It creates an architectural schema. Then the work moves into Terraform generation. But this is the important part. We do not stop there. The next stage is validation. The AI generated Terraform must be reviewed. It must be checked for structure, security, naming standards, it must be checked for remote state, checked for resilience, cost awareness. And then the output can be packaged and delivered. This is what n8n is doing here. n8n is not just calling an AI model, and it is coordinating the full workflow. So prompt intake, Bedrock reasoning, architecture schema, Terraform generation, validation loops, a self-review, and then output package and delivery. This is how we move from a random AI response to a controlled architecture automation pipeline. Now let's look at the prompt builder section. This is where the demo becomes more practical. Instead of just typing a vague request, we can select the architecture components we want. For example, here we can select VPC and subnets, application load balancer, ECS forgate, RDS and private subnets, NAT gateways, IAM roles, CloudWatch, security groups, auto scaling, S3 and Terraform state. Now, in a real implementation, these selections could come from a form. They could come from a chat interface, right? They could come from a business requirements document. They could come from a solution design questionnaire. But the goal is the same. We're turning architectural intent into a structured infrastructure blueprint. When we click generate, the system creates a Terraform module structure. And notice something important. A serious Terraform output should not be one giant messy file. That is not how the mature teams work. A better structure separates the infrastructure into modules. For example, a network module, a security module, an ECS, RDS module, IAM module, monitoring module, a variables file, an output file, a provider configuration, and the backend configuration, and a README file. This is how we make the output reviewable. This is how we make it maintainable. This is how we make it easier for an architect or DevOps engineer to improve before deployment. And this is the key phrase, right? AI should not replace structure. AI should produce a structure. Section 4, validation loops. Now we come to one of the most important parts of the demo, validation loops. This is the part many AI demos miss. Generating Terraform is easy. Generating reliable Terraform is much harder. If you check a powerful AI model to create Terraform, it usually produces something, but can you trust it? Does it follow your naming standards? Does it avoid public database exposure? Does it use least privilege IAM? Does it avoid hard-coded secrets? Does it use remote state correctly? Or does it support high availability? Does it consider cost? Does it match the original requirement? These questions matter, okay? That is why a professional workflow needs validation. In this demo, we show checks such as Terraform format, Terraform validate, IAM least privilege, network exposure, secret management, naming conventions, remote state, multi-zone resilience, cost awareness, and AI self-review. Now, in a real production version, I would take this even further. I would include Terraform validation, security and scanning, InfoCast, GitHub pull request review, policy checks, AWS config, and human approvals. So please remember this. This is an interactive, this is a demo created for teaching, okay? This is not a production deployment system by itself. In a real environment, we would review, validate, scan, and approve everything before deployment. This is not blind automation. This is architect-supervised automation. That distinction is very important. The AI drafts, the workflow validates, and the architect approves. All right, section 5, self-healing infrastructure. Now let's look at the future direction, right? Self-healing infrastructure. Once infrastructure is deployed, the same AI-driven workflows can help with operations, Imagine the scenario. CloudWatch detects that CPU utilization is too high, or an auto scaling graph fails, or there is a cost spike, or AWS config detects security group drift, or the load balancer reports failed health checks. In a traditional environment, an engineer receives an alert, logs in, investigates the issue, reads logs, checks metrics, then decides what to change. But in an AI assisted workflow, the operational signal can trigger an analysis pipeline. The system can summarize the incident, it can identify likely causes, it can recommend a remediation, it can generate a Terraform change, it can open a pull request, and then the human architect or engineer can review and approve it. That is the realistic path to self-healing infrastructure. Not uncontrolled AI making production changes, not blind automation, not a system that changes your cloud environment without your review. The better model is supervised, auditable, human-approved remediation. That is where the future is going. AI can help detect, AI can help analyze, AI can help recommend, and AI can help draft the fix. But the architect remains accountable for the final decision. Now let's talk about what this means for the role of the cloud architect, right? The old model was, I know the architecture, so I manually configure it. The new model is, I define the intent, then supervise AI generated infrastructure. In the old model, much of the work involved clicking through the AWS console, writing boilerplate Terraform, manually creating IAM policies, generating standard modules, formatting variable files, documenting deployment steps. Some of that work is still important, okay? But much of it is repetitive. And repetitive work is exactly where AI and automation can help. The new architect spends more time on higher value responsibilities, designing resilient architecture, crafting AI system prompts, building AI or automation workflows, validating AI generated output, creating infrastructure guardrails, governing intelligent systems, managing cost, managing compliance, supervising AI orchestration. But this does not mean AWS expertise becomes less important. Actually, it becomes more important. Because if you do not understand AWS, you cannot validate the AI output. If you do not understand networking, you cannot judge the VPC design. If you do not understand IAM, you cannot spot dangerous permissions. If you do not understand fault tolerance, you cannot evaluate resilience. If you do not understand cost optimization, you cannot identify waste. The future cloud architect will not be judged by how fast they can click through the AWS console. They'll be judged by how well they can design systems and how well they can use AI as a force multiplier. So let's bring this together. The point of this lecture is not that AI replaces cloud architect. The point is that AI changes the work of the cloud architect. The repetitive drafting work becomes automated. The architect moves up the value chain. Instead of spending most of the day clicking through screens or writing boilerplate code, the architect focuses on design quality, security, resilience, cost, compliance, governance, scalability, business alignment. AWS Bedrock gives us the intelligence layer, n8n gives us the orchestration layer, Terraform gives us a repeatable infrastructure layer, and the architect provides the judgment. That combination is very powerful. This is the future I see for cloud architect. Not AI replacing professionals, but professionals who know how to use AI becoming much more powerful. So if you're a cloud architect, DevOps engineer, AWS learner, or automation consultant, this is the skill set to build. Learn cloud deeply. Learn infrastructure as a code. Learn AI orchestration. Learn validation. Learn governance. Because the future belongs to the people who can combine, expertise with automation. That is what I mean by automating the architect. And if you want more step-by-step AI, AWS, and automation playbooks, visit thedigitaltutor.net. Whether you're launching your first AWS AI model or automating complex workflows, expect step-by-step playbooks, real-world demos, and pro cheats. Signing off till next